So error in statistical decision, also because we collect sample to make decision, right? The sample have variability, right? Sometimes you may not be able to collect the data that accurately reflecting the underlying population, right? Because sampling error, right, can be, suppose you want to collect the height of the population, right? Sometimes you may have error collecting only the tall people, or maybe oversampling on the short people, right? So maybe you have this problem. Okay, so there are two type of error you can imagine in the hypothesis testing. First is you the null is right, but you happen to be getting the wrong data, right? Happen to be the data, not only happen, maybe your sampling mistake, right? Error happen to be you collect the height, as we said. Either you get the very tall people or very short people, right? Not the normal people. Then the null should be correct, but you reject it. Okay, the null is true, okay, but you reject it. That is called type 1 error, and we define the probability of type 1 error is called alpha. Okay, and probability type 2 error, okay, is fail to reject the one null. Null is wrong, but you did not reject it. Okay, fails to reject, and if it's false, then we will call beta. Okay, this is type 2 error. So another terminology is alpha is also sometimes referred to level of significance. Okay, and we will call 1 minus alpha confidence coefficient, okay, or similar to the confidence level when we talk about interval estimate, the last chapter. And the power of test, right, is 1 minus beta. Okay, the beta is type 2 error, so 1 minus beta is the power. How powerful it is, it basically false, I can reject. Okay, that is very important thing, right? Because we want to reject the wrong actional is the power of the test. Okay, so there's a extra trade-off, okay, of between alpha and beta. Okay, so let's see the false situation, right? And when x now is true, right, the null is true, and you do not want to reject it, okay, which is 1 minus alpha, okay, and you reject with alpha, it's a type 1 error. And when x now is false, right, you want to reject it, right? If you don't reject its beta, the power of test is 1 minus beta. And alpha is something we can choose, rely, basically just rely, basically we allow how large the sampling error we allow, right? Because this is like, if true, we reject it, right? So it's how the tolerance of sample error, right? If we want alpha is very small, right? We don't want to commit the error, then we require the rejection is more stringent, okay? And usually there's a trade-off between alpha and beta, okay? If you want smaller alpha, then you need to smaller beta. And for a given alpha, if you want to reduce beta, it's possible only by having a larger sample. Okay, that means if you're a larger sample, then things can be get okay.